Hi, my name is Dave Lannom with Monroe Training, and welcome to today's segment on circuit faults. Today is part three, the short to ground. Here's our agenda. First of all, we're going to talk about why short to ground. Just a reminder that great mechanics do great electrical work and diagnosing a short to ground. We'll do a quick demonstration and then we'll do a summary. We're going to use a lot of previous training today. We're going to be using the module on schematics, schematic symbols, as well as basic electricity and relays, digital volt ohm meters, circuit construction, electrical laws, and we're going to review some of the material again from open circuits. So, why are we talking about circuit faults? I mean, just a reminder, electrical diagnosis comes in number 8 in the top 10 auto repairs, with O2 sensors at number 3 and ignition systems at number 7. When you consider 3 of the top 10 repairs require you to be able to do electrical diagnostic work, you can't underestimate the value of electrical testing in your diagnostic tool set. With the proliferation of electronics in vehicles today, we need to be absolutely sure we never send a guest to a competitor for repair. So, by understanding the testing of the four basic circuit faults, we can quickly and accurately provide a confident diagnosis to the guest. And remember, a confident, accurate diagnosis builds guest confidence, resulting in the referral of friends, family, and coworkers. So, when we start to talk about short circuits, the first one we need to talk about is a short to ground. And a short to ground, by definition, is simply an unintentional routing of power to ground. The component, in a lot of cases, is not operational. In some cases, the component operates continually. Now, in the cases it's not operational frequently, it's blown a fuse. Remember when we talked about in the last segment that a wire left undisturbed is pretty much going to be fine for a long, long period of time. But where did the fault begin to happen? The fault began to happen at the point of movement or where wires started to rub together. This can happen as a result of, like we said with the BMW, the trunk opening and closing. Some cases, the hood opening and closing. A bad motor mount causing the engine to rock, stressing the wiring harness. Or even when a guest is pulling in a little, maybe a little bit too far across a curb stop. Remember, any place that there's motion, that's where the first place that I'm going to begin to look. But where did we start all this? We started the diagnostic process back with a digital voltometer. That's the tools that I want to use. And the tool that I'm using, I need to set on the ohm scale. Remember, when I'm measuring between a connector and ground and I have zero resistance, that's a completed path to ground. And on the other half of that, if that meter says OL, it means out of limits. And at that particular point, I know I've exceeded what the meter can read, but more importantly, it's not likely a short to ground at that circuit. So when we went back to the schematics, remember, I'm not going to review all the pieces again that we talked about inside all data. So what I'm going to use is component locations, harness routing, the connector identification, as well as terminal identification as we look at this basic horn circuit. Now, remember in the relay section what I need. On the low current side, I needed battery positive power, which in this particular case came from the 250 amp fusible link. Then from there, to ground that relay and make the low current coil into the load, I simply needed to apply ground when the horn button was pushed. On the other side of the circuit, I knew I had battery positive power coming from that same fusible link. But when I closed the switch, now I energized another fuse. And at that point, we ran battery positive power to the horns and from the horns to the ground. Nothing changed with anything that we discussed in relays. All we needed was a source, a load, and a complete path for current to flow, whether that was on either A, the control side of the circuit, which was a low current coil, or B, the higher current horn side. So remember how the circuit operates when a fuse blows or when I have a short to ground tells me and it will tell you exactly where the circuit has failed. I mean, if we look at it this way, if I ran a short to ground on that red and yellow wire before it made it to the fuse block, I'd burn up a 250 amp fuse. And I can tell you, there'd be a lot more working than just the horn not working. And I would blow the 250 amp fuse. And I can guarantee you there would be quite a few items that would be not working. And the horn would probably be not the highest priority we were looking at. But from there, if I had a short to ground at point two, again, that short to ground was before the horns, which in this case were the loads. So as soon as I put my hand on the horn button, I'd close the switch inside the relay. It'd blow the 20 amp fuse. And again, the horns wouldn't sound. So fuse is only blowing when the horn relay is activated. So if we take a look at point number three, if I ran a short to ground there, what would I have? I'd have battery positive power coming into the low current coil. I'd be grounding the low current coil, which would be closing the switch. And since that particular fuse is hot at all times, I know that that horn would sound continuously, whether the key was on, the key was off. So let's take a look at another point. Let's take a look at if I had a short to ground at point number four. Now, once again, the horn would be sounding continually, but it would only happen when the key was on because I'd have to provide battery positive power to switch the ground through the body control module. So as you can see, whether it's point one, two, three, or even four, I can make a determination how I'm going to attack and diagnose this circuit simply based on how the circuit operates. Now, remember, the first thing that we did is we went back to the circuit, we broke that circuit down a little bit further. We looked at our connector view, and that connector view would tell me, okay, what's the circuit number? All right. And not only that, as I looked at that circuit number, it'd tell me exactly what connector, where the connector is, and what it looks like. So if I was looking in this particular case for the horn switch signal coming from 18, I'd go down to the third row, four over, and I would have 18. So remember, we went into connector view to pull this data. Now, let's do a little bit of an exercise here. Let's say we had a short to ground at point number four. So remember, at this particular point, I don't want any battery power flowing through the circuit while I'm testing a circuit for ohms. So what I'm going to do is I'm going to pop the relay out and I'm going to measure between the low current side and ground. And what would I expect to find? What I would expect to find at that particular point with key on, engine off, I would have 0 ohms because I had a complete ground path running through the circuit. Now, again, I still have to find out where that is. So I unplugged the connector, both X5 and X3, and at that particular point, what did I have? I knew when I unplugged it because the current flow, the ground switch was all the way down at 4 with X3 unplugged. I knew at that particular point it read out of limits. So I had effectively eliminated at that particular point a short in the brown and white wire. But now, with that same terminal unplugged, when I measured it pin 18 back to ground, because the short to ground it was at point 4, I had a complete path for current to flow. But then what did I do? I unplugged X1 and it went out of limits. So now I knew my short to ground was somewhere between the steering wheel airbag coil and terminal number 4. So we kept going. We unplugged the terminal at X2 and voila, we still had a complete path to ground. So I knew it wasn't on the horn side switch. It had to be at that particular point between terminal 4 and terminal 2 of the horn switch. So with that said, using the meter, we were able to quickly identify where it was. Now, I did take the long way there, and I'll tell you why I did that. I took the long way there because I wanted to make sure we knew how we could check the entire circuit. But now, as technicians, let's talk about what was the best path that we could take. And when I look at the best path for me to take, I look at the fact that what I knew is with the absence of motion, that circuit would probably operate pretty much normally. So where's the motion? The motion is between the horn switch, the steering column, at the airbag, at the clock spring. So I'm looking at a place where there's motion. And that's exactly where I found this particular short to ground. So while we always want to use common sense and start at the area that's most likely, I did want to make sure that we had the ability to test the circuit from end to end. So let's take a practical look at this and do a live demonstration on a car. So remember, always keep it simple. Always think your way through it. Look at how the circuit acts, and that will help you determine where the fault in the circuit is. Use the right tool for the right job. Always the follow schematic, and remember, the connector view is going to keep you on the right track. And remember, if you ever have any doubt, if you need a little bit of extra assistance with the advantage of having rescue lens, don't hesitate to reach out to All Data Technical Support. They can help you make sure you're measuring the right connector at the right place. Hope this section's been helpful for you. Thank you and have a great day.